Okay, so just as a sort of a finish up to the review and a lead into the first principles work, we're going to look at a couple of questions here of a very specific form and simplifying them. This is something that's going to lead into the first principles section, and questions in the first principles section will look like this. So we're going to concentrate on just making sure we can simplify them first, and then we'll worry about how they apply to calculus kind of in the next few days. We'll be in this first section for a couple of days for sure. So basically the question just says simplify, and I'm given this as a starting point. And so if I see a binomial here to some exponent, the only thing I can really do here is expand it. And so just if you weren't sure how to expand a cubic, basically you can treat it like a square and then multiply by the third binomial. And so I've done that. I won't go through the actual steps. Assumedly you can follow the math. If not, you can just kind of do it on your own and make sure that you get to the same answers. So I've expanded the 1, then I multiply that through. I apologize, the colors here look like they didn't show up very well. I did have a couple of different colors going just to try to make things a bit clearer. I guess the blue is okay down here. And so what ends up happening on this question is, as I simplify the numerator here, I see there's an h cubed term. There are a couple of h squared terms that give me 6 total. I have 12h, and I have 8 minus 8, so the unit term disappears. And then basically the last step of these questions will be I have a common factor of h throughout the numerator here, factor out the h, then divide the h's, and my final answer is here. I've stated off to the side that h's cannot be 0, of course, because of this simplification. Good habit to get into, but for our purposes, it probably won't matter too much if you don't write that down at this point. I don't think that the answers, when you look at them from the textbook, will say h does not equal 0 in each question. But recognizing that, of course, anytime we're simplifying something, if we do divide out a term, we have to remember that it couldn't. There are values that couldn't be allowed there in the denominator. Sorry. So similar looking question, but obviously a little bit different. So essentially we have a term minus another term, and you'll see why we're using h, again, basically tomorrow, as opposed to x or some other variable. It certainly doesn't matter, of course. And so here I have two fractions on top, and the only way to subtract two fractions, regardless of the fact that there's an h here, is to find a common denominator. The common denominator, of course, is the 8 plus h from here and the 8 from here. So I just kind of noted that off to the side. And to put the two terms in terms of having that common denominator, I multiply the first term by 8 over 8, the second one by 8 plus h over 8 plus h, and then it's a matter of simplifying. So I have 40 minus, and just sort of treated the minus, so we'll worry about it in a second. I have 5 times 8 plus h is 40 plus 5h. Once I have that common denominator, of course, the purpose of that was to get to the point where I could simplify into a single expression. And so I have 40 minus the 40 plus 5h. 40 minus 40 is 0. Negative 5h, or minus 5h, will give me negative 5h here. And then when I have this three-tier fraction, I tend to look at it like this fraction divided by the entire value of h. And so if I rewrite it in this form, it's a little bit cleaner looking. And of course, when we're dividing by any term with fractions, we flip the second term and multiply. And so I have negative 5h times 1, 8 times 8 plus h times h. And again, our h's will divide out. Now, what we're doing in these, or what we're looking for in these types of questions, is the opportunity to divide out the h. And again, we'll see why sort of in the next day or so. But for now, you should get to the point where your numerator is either factored or can be factored, and then again the h's will divide out. And again, I sort of stated off to the side that h can't be 0, just to keep that in mind. And this is our final answer. Rationalize the numerator one more time. Or sorry, rationalize the numerator this time. Essentially, we're still simplifying, but the question obviously is, again, just looking a little different. we have a term here, or an expression here, let's say, minus another expression here. And so again, the form is similar to what we had, all divided by h. When I have a square root, though, there's not a whole lot I can do other than what we call rationalizing it. To do so, we multiply by the conjugate. And the conjugate, the conjugate is the same expression exactly with the subtraction symbol changed to an addition symbol. And we'll sort of see why that works in a second. So this was just a note off to the side saying this is the conjugate of the square root that we had minus the 3. So we use the square root that we just had exactly the same plus 3 instead. And what happens is, of course, because we're multiplying by the fraction, multiplying numerator and denominator by the same value doesn't change anything, so that's fine. And what you'll see happens is when I multiply the two roots, I end up with that same exact expression, of course, without the root. It's like, what is root 9 times root 9? Well, it's positive 9. It's root 81, which is just 9. And so this root then times the plus 3 is plus 3 times the root. Negative 3 times the root is negative 3 times the root. And negative 3 times 3 is negative 9. And of course what happens is this middle term subtracts out. So you have the same term, positive and negative, and it goes to 0. What we have here really is just a difference of squares on top. It's this value minus something, this value plus something. So this is the factored form of the difference of squares. And so when we actually multiply it through, you'll see that the square roots disappear from the numerator. They still appear in the denominator, but that's fine. And as did in the other cases, our units subtract out, and so we end up with two terms now, both of which have an h. Factor out the h, and then divide them out, and we'll end up with a final answer that looks like this. Okay. Now again, the reason we're doing this is it's going to be the types of questions we run into as we get into first principles, which is the introduction to calculus. But I thought maybe just practicing a few of these questions as a follow-up to the review we already did with slopes will kind of get us prepared to the point where we can start on the actual content probably next day. And you'll have done at least a little bit of work with this so that you're not trying to combine the two. What are the concepts along with what is the work that I have to complete?